Question 4 from the AAHL exam is here, which you'll see is identical to question 5 from the AASL exam, which is here. So the following recording is my work solution from the question 5 from the AASL exam. Question 5. Find the least positive value of x for which cos of x over 2 plus pi over 3 is equal to 1 over the square root of 2. Okay, cool. Let's highlight this idea of the least positive value of x. And then, I've got a big expression there. Right, so first things first, with this question, I'm going to say let theta equal x over 2 plus pi over 3. And then therefore that means I can say there cos theta is equal to 1 over the square root of 2. Yeah, do that again. Okay, so if you're not familiar with these, with your exact value triangles, I would encourage you to sort of commit them to memory. Here I've got one here. So here is an exact value triangle, which is effectively a right-angled isosceles triangle, where the two sides that are the same length are length 1. And then if you run Pythagoras theorem, you'll find that the hypotenuse is the square root of 2. And then from here, you'll be able to find the exact values of cos, sine, tan of 45 degrees or pi over 4. Okay, so here is the triangle here. So therefore, we can say that theta here will have to equal pi over 4. All right, since pi over 4 here, the adjacent side is 1, and the hypotenuse is root 2, and cos of theta is equal to the adjacent side divided by the hypotenuse. Okay, so therefore we'll put theta is equal to pi over 4. Okay, so moving on from this, now let's so now we've got theta is equal to this and theta is equal to this. So we can say there then that pi over 4 is equal to x over 2 plus pi over 3. And if we rearrange this for x over here, let's just go across here. So x is going to equal pi over 4 minus pi over 3, and I've forgotten to times by 2, but we'll bring that in. But here we've run into a bit of a problem, since already, before I even times this by 2, what's in the bracket here? Pi over 4 minus pi over 3. This here, this is less than 0, okay? Which is a problem, okay? Because we need to find the least positive value of x. All right, so we'll note that and say this is less than 0. Okay, so therefore theta being equal to pi over 4 isn't valid. Well, it would satisfy this equation here, but it's not the least positive value of x. Oh, sorry, of theta. And then this would give us a negative value of x, which would satisfy the equation, but doesn't answer the question because we need the least positive value of x. So here I'm going to give you a bit of a cos theta rule, or you can sort of figure this out from the cos graph if you draw it out. But a bit of a hard and fast rule is, so I'll write this in blue, cos theta is equal to cos 2 pi minus theta, or if we were in degrees, we could put cos 360 minus theta. And so then therefore, okay, if theta is equal to pi over 4 here, then another possible value for theta would be 2 pi minus pi over 4, which is going to give us 7 pi over 4. Okay, because this would turn into 8 pi over 4. Then we get 8 pi minus pi. And so, yeah, we get 7 pi over 4. All right, cool. So then now let's move on and let's try and use 7 pi over 4 for our theta. Okay, so we'll take this expression here that we had for x. All right, let's substitute in 7 pi over 4 instead of sorry, 7 pi over 4 instead of pi over 4. So we'll just, where's my rubber? Get rid of this, lob in 7 pi over 4. Okay. And then now we're going to have to do a bit of working. So let's say this is going to equal 2 lots of. Now to get a common denominator here, we can go with the standard with 12. Okay. So we're going to go with 21 pi. All right. Because, to get 4, the denominator of 4, to become 12, we have to times it by 3. That means we have to times its numerator by 3 as well. So we get 21 pi. Then for the pi over 3, we have to times the 3 by 4 to make it 12. That means we have to times the pi, this pi here, by 4. Okay. So then we go minus 4 pi. And we had a common denominator of 12. All right, sweet. And so then this is going to give us 17 pi 12. Yeah, good. Sweet. Okay, cool. And then that is going to equal 34 pi over 12. And then to finish up, we have a common factor between these two of 2, so we can change that to 17. Change this to 6, divide them both by 2. And so our final answer is x is equal to 17 pi over 6. Okay, and now that is the least positive value of x that satisfies this equation up here. All right, just to expand quickly on the magic triangle, exact value triangle. Okay, so here, this one here, this is the isosceles right-angled triangle. Okay, where the two sides of the same are length of 1. You can then use Pythagoras to find out that the hypotenuse will be square root of 2. And given it's an isosceles triangle, we know that the base angles have to be the same. So, and we know the angles of the triangle add up to 180. So they both have to be pi over 4 or 45 degrees.